Some universities do that. The thing is, sometimes it doesn't make sense. Like that you already got tested. Let's say that you took advanced structure analysis with me, and you passed the test, and you got already tested in the subject. So why would I test you again? It's gonna be a waste of time. So basically, from my perspective, yeah, the qualifying exam need to qualify you to be a good researcher. So if you are good, because PhD is all about research. So giving you some papers, I believe, is much better. Because I remember when I was taking my qualifying exam, it was much harder than here. It's not only a subject. Like it's not only I'm gonna teach you, I'm gonna tell you, I'm gonna get tested in advanced structure analysis. You get tested in all the structure analysis. From basics, advanced, everything in the structure analysis, you have to be prepared. Everything in concrete design. And so you pick like subject, anything in mechanics of materials. So I believe here was a little bit much easier. Sometimes it's better that you get examined in something that is constrained. So you said that, oh, I'm gonna study this and I'm gonna examine this. But if you give me a paper with an open concept and ask me anything from anything, maybe it's a little bit difficult, but I believe it will have some rules, like at least you have the thought process good. So it's good. I mean, it's gonna be less effort. I believe the main purpose from changing the qualifying exam part is to like not wasting your time. Not wasting your time is studying exams that you already passed, and just focus on something that's not gonna take that much time to study. Maybe one paper, you read it, you understand it, and you get some questions about it. Just make sure that you understand the paper very well. And it's gonna be easy, like you read it, if you stuck with something, you email the authors, oh, how did you do this? How did you do that? So, yeah, I believe it's much better. It depends on you, but anyway, I know that you guys had some problems with the homework, right? I got some emails. So when is the homework due date?
It was yesterday.
It was yesterday?
Yeah.
So maybe we can do extension until the end of the week, and I'm gonna cover some stuff today. And if I didn't cover your questions, you ask me, oh, how we do that, okay? So that's one thing. Where all of you had access to ArcGIS? All of you, or didn't have access? And why is that?
I did at the beginning. I was connected to the FIU's computer.
I don't think you have to connect to the remote connection. If you have Citrix set up on your computer, you can access through Citrix. But it has steps. You have to connect to VPNs, you have to install Citrix, you have to do, because I remember when I was doing it, it's a lot of steps. Maybe you book an appointment with the EIC and let them do this for you. Like they show you the whole process, how to connect all that. I still have problem with remote connections. I cannot get like connected to my computer, so it keeps on and off. So.
Well, last night it was totally down because they were doing maintenance.
How about ArcGIS Pro? If you go on Google and as I show in the first video, type ArcGIS Pro FIU, you will have access to download the software and access it with your FIU ID, like the Panther ID.
I tried that, but they were asking for a business email.
Why?
I don't know.
Did you guys try to download ArcGIS Pro?
Yeah.
It worked?
Yeah, it worked. Because I already had the class previously.
Did you have to have a business ID or
No, I
something?
think you just signed through the SSO.
Maybe you guys, yeah, try to ask each other, see how you install the software. I believe it's not that difficult.
Like,
But we need to have it.
Is it better than ArcMap or?
Well, ArcGIS Pro is a little bit heavier, but the visualization is much better. But they both are the same thing, like they have the same tools.
Okay. Because I had some problems.
I'm gonna show how to do stuff in ArcGIS Pro and like show both of them, how they look similar, same thing. And to be honest, the idea is not to teaching you ArcGIS. ArcGIS is just a tool to visualize our results. So if you're stuck with something, anything, that's what I do till now. I don't know any, like the 100% of ArcGIS Pro. Still, if I wanna do something, I go to YouTube and search how can I extract value from a raster map on ArcGIS. Then I watch a video and I see how to do it. So you can even do it in Google. They show you the steps one by one. So if something that I didn't say, you go to Google and ask, it's gonna show you step by step how to do the things.
The problem sometimes you do the same steps.
and then you get some result. That's what happens. So that's actually how you are gonna be a problem solver. You get an error, so you take this error to Google and see what is the source of this error. That's what I do till now, even in programming, MATLAB, Python. I get an error and I put it in Google or put it in ChatGPT, and it's gonna tell you. Even you can put your code in ChatGPT and it can prove it for you. So it's gonna tell you exactly where is this error coming from, and you keep running after error. That's, I believe, you get to the higher level of problem solving. Because if everything is easy, it's not gonna be that good. Because you want problems to solve. Then when you'll learn from your mistakes or from the errors that you get. Oh, when you get this error, I know how to tackle this. You know. Okay, so that's what I still do till now. Sometimes I stop. But I don't stop. I take the error, put it in Google, put it in ChatGPT, put it in any AI, put my code, my whole code, and see where is this error coming from. All right? Okay, so let's today continue on the subject that we started last time. Last time we learned ArcGIS. We learned the main tools that we have, how to import shape files, how to import CSV file, and the CSV file need to be like comma delimited, so it needs to be like a specific, not the .xlx, so not this one. It has to be a specific shape, and then how to convert this Excel file to shape file, like how I can convert this, but it needs to have latitude and longitude. It needs to have the coordinates of each point, and once I converted it to point, I was able to convert it into raster maps. Do you guys remember when we developed the wind hazard map? Okay. So today I'm gonna teach you how can, let me record the screen. Alright, so today I'm going to teach you how, if we have a flood hazard map and we have a community, and if we want to know what is the flood depths or the hazard intensity at each building. This is applied for any hazard. Like let's say that we have San Francisco building information, like we have the shape file of the buildings, and we have the earthquake hazard intensity map. We can overlay them together and ask GIS to extract the spectral acceleration of the earthquake at each building. If you have a wind speed map and you have a community, you can overlay the wind speed map over the community and identify what is the wind speed at each building. Same thing with flood. I can get the flood hazard map with our community, overlay them together, and do some ArcGIS analysis and extract the value of the flood depth at each building. That's a very, very important step when it comes to risk analysis. We want to know the risk at each building. So how we can do that? GIS can do this for you, okay? So that's the first step before I do the fragility analysis, because if I want to do fragility analysis, you want flood depths to start from, or you want hazard intensity to start from, so that you can identify. If you guys remember the fragility, it was a 2D curve that has hazard intensity on the x-axis and probability of failure on the y-axis. So to get the probability of failure, you need the hazard intensity. You need the flood depths, or you are dealing with wind, so you need the wind speed. If you are dealing with earthquakes, you need the spectral acceleration, so you need the intensity. So that's the first step that we need, okay? But sometimes, like, the fragilities that we use needs, like, we cannot use the hazard directly. Like, we cannot use what we get from the hazard map directly. Like, let's say I give you a wind hazard map, like the one that we developed last time for Hurricane Michael. Let's say that this hazard map was, I told you that the wind speed that measured at this point is 10 minutes average wind speed. Okay, because the wind speed sometimes people when they measure it, they take the 10 minutes average, they take 15 minutes average, they take 3 minutes average. Like there's lots of records of the wind speed, but they take the average every 3 minutes or the average every 10 minutes. But the fragilities that are in the literature in the vulnerability function, like if I say that this is my fragility and this is let's say this is a fragility curve for a wind with something, and this is 1, and this is the probability, and the curve is with something like this, all right? Here, the fragilities in the literature that has been developed for wind speed, the wind is V3 second. Why? Because most of our design of the structure is based on something is called 3-second gust wind speed. That's most of the design in the literature. Like when we design buildings, when we design everything, we need something is called the 3-second gust wind speed. So we need to convert the wind speed from average 10 minutes to average 3 seconds. Okay? So that's what we need here. So there's conversions in the literature. So let's say that my map that I developed from last time is 10-minute average. I go in the literature and I get a table and see how can I convert it from 10 minutes to 3 seconds. So it needs a little bit of conversion, okay? Same thing with the spectral acceleration. There's something called spectral acceleration and design acceleration. So you need to use some conversion between from the spectral to the design acceleration. Same thing with flood depth. Like let's say that you have a building like this, and let's say my foundation is here. It's a slab. Let's say it's not slab on grade. Like this is the ground elevation. Let's say this is the ground elevation, and the vertical floor elevation is a little bit higher, like here. We call this FFE, vertical floor elevation. To get from the ground to the vertical floor elevation, you have to take some steps, something like this, all right? Okay, so usually when we do vulnerability analysis for buildings, the damages start from the FFE. As soon as the water didn't get inside the house, you are protected. Somehow you are protected. Still, you might end up having flooding in your crawl space area. We call this crawl space area because usually there is a vent here and you can't crawl to check your HVAC systems or heating system or something. Okay, so let's say I have a flood depth at this level. We call this the water surface elevation. By the way, all what I'm talking about right now is elevation, it's not height. Do you guys know the difference between elevation and height? Elevation is something relative. Height is something absolute. So the elevation is always relative to the mean sea level. Okay, so maybe my elevation here, maybe on the ground of this building, can be, I don't know, 100, maybe not 100 because we are close to the ocean, maybe 30 foot. So we are 30 foot higher than the elevation at the ocean or the mean sea level. But it's a 0 because it's the ground. I mean, like it's a 0 height. Okay, so this is, let's say my ground elevation is like 100. My water surface elevation is 101. My vertical floor elevation is 102. Okay, so that means that the flood depth here is 1 foot, right? Okay, so sometimes we deal with elevations, sometimes we deal with heights. Okay, so you have to be careful what you are dealing with. Are you dealing with elevations or are you dealing with heights? Usually, hazard maps sometimes comes as a water surface elevation or a flood depth height. So if I told you, I give you the flood depths and the flood depth is 1 foot, so I go 1 foot from the ground and go 1 and make the water surface elevation. Okay, so you have to be careful with this. All right, so usually what we have when we do flood vulnerability analysis, number 1, you are gonna get something is called DEM. What is DEM? It's called digital elevation map. The digital elevation map gives you the ground elevation of the area, and this is one of the key maps for most of the vulnerability analysis related to flooding. The digital elevation map, because this is where you know where's the ground of the elevation of the ground, this ground. all right? So, and by the way, most of the digital elevation map is elevation. That means it's measured with respect to the mean sea level, okay? All right, so that's number one. The second important piece is the flood. The flood can come in different ways. As I said, I can give you water surface elevation. Like this. If I give you water surface elevation, so if you want to know the flood depths, let's say flood depths FD, measured from the ground elevation, flood depths measured from the ground elevation is going to be equal to the water surface elevation minus the ground elevation. Is that right? So if you want to know the flood depths measured from the ground elevation, you subtract this elevation from this elevation, so you can get the difference. And sometimes we want to know the flood depths measured from the FFE, the versus the floor elevation. And this is going to be the water surface elevation minus the FFE. And in this case, the flood depths measured from the FFE is negative. That means that the water didn't reach the versus floor elevation. So we can put it as 0. All right? But if the water surface elevation is here, that means both the flood depths measured from the ground elevation and measured from the FFE is going to be positive because the flood depth is above both elevations, right? Do you guys all get that? Is there any problem? Okay. Sometimes I can give you the flood hazard map not as a water surface elevation. I can give you the flood hazard map as flood heights. Like the map give you the absolute flood height measured from the ground. Okay? Like it tells you, oh, this flood depth is 1 foot. Right away. So you don't have to do this subtraction. So the flood depth measured from the ground elevation is directly the flood height. So you don't have to do this subtraction. But what if I want to know the flood depth measured from the ground, from the versus floor elevation, and I give you the flood height, not the water surface elevation? If I want to do that, so I have to do a extra step. First, I have to find the water surface elevation from the flood height. The water surface elevation from the flood height equal the ground elevation plus the flood height, right? Here, this is the ground elevation. And if I give you the flood height, we call it flood height. So this plus this is gonna give you the water surface elevation, right? Then after you get the water surface elevation, you get the flood depths measured from the FFE by taking the FFE minus the water surface elevation, which is this, sorry, the opposite. The water surface elevation minus the FFE. Okay, so I either give you directly the elevation, so you have to be careful. Am I giving you elevation or I'm giving you absolute depths, right? So that's one thing. And you have to look, what is your fragility intensity measure? Like when we talk about flooding, there's some fragility function that take the flood depth measured from the FFE, and some of them they use the ground, the flood depth is measured from the ground elevation. Okay, so you have to be careful with that. What is the intensity measure? So maybe I have to calculate both. I have to calculate the flood depths measured from the FFE and the flood depths measured from the ground elevation. Usually, let me tell you this, if the building on the ground, like most of the buildings in Florida, they are all slab on grade, most of the buildings, not like the Midwest. Midwest, they are mostly crawl space buildings. If the building is right on the ground and there is no steps like this, like the building is just like that, like here, this is your slab and here is your door, and the building is a slab on grade. If it's a slab on grade, so basically we can use the flood depth measured from the ground elevation, because mostly or most of the time the ground elevation is the same like the versus floor elevation, or maybe they are 1 foot difference. Okay, all right. But if the building is crawl space foundation, that means that there is a space here. So the ground elevation is not like the versus floor elevation. Okay? And sometimes some people put mechanical systems here, like they put their AC unit, or they put the AC unit outside, but here there's like the mechanical systems, the pipe, the electrical system. So there's a lot of components below the first floor elevation that you need to capture in the damage. So usually we make the flood depths measured from the ground elevation. Okay, so if you have a crowded space, so the flood depths need to be measured from the ground. But if you have a building on a slab on grade foundation, that means that the FFE is the same like the ground elevation, and you still can use the FFE, right? Okay, so this is just like I'm showing you what you should do when you do vulnerability analysis, but the main idea is what hazard intensity are you dealing with? You have to look at the map that you are downloading. Is it elevation or is it height, okay? All right, so let's deal, last time I showed you how we talked about Galveston, right? Do you guys remember? There was an island. Let's get back to it. I'm gonna drop this file here. So this is the building polygons, like if I zoom in. It's a little bit slow. So that's the building polygons, and if you want to show the map, I told you that you can add a base map to these building polygons, so that you can see where are these buildings with respect to the city. So you can choose from multiple base maps, and everyone has different views. Sometimes people would prefer the imagery one, some people would prefer the topographic one. So maybe if you want this time, we can deal with the topographic map, like I can put this map. Whatever that works for you, just keep using it. Same thing with ArcGIS Pro. Like if I open ArcGIS Pro, my computer is screaming. Okay, so here you can also do the same thing. Let me close ArcGIS Pro. Okay, so this is, let me record this screen again. Right, so I was about to put a base map here just to know the location of the buildings. So basically I go here and add data and I add a base map. And I'm gonna add topographic maps. And I was about to say that you can do the same thing with the you guys can see this. So I can do the same thing with ArcGIS Pro. I can drag and drop my shape file, so I can go here and drop my files here. Or basically you can add the data like from here and choose the location of your data. So like you can go here, add data, and then maybe you copy the location of your folder. And I can come at ArcGIS Pro here and put the location of my folder, or I can browse actually the location of the folder, but I usually find it much more easier to copy where's the folder at. And put it here. And you pick whatever shape file, so basically we want the Galveston Island buildings polygons, and I can say okay, and it's gonna get loaded. Alright, so let's get back here and see if the shape map is loaded. Still taking some time. So here our layers is gonna start to show up on ArcGIS Pro. I'm just showing you both softwares, how they look like at the same time. So just to know that the process is similar. But since we have two softwares at the same time, along with recording and projecting the screen, it's a heavy load on my processor and RAM. So I have an old laptop. Just taking a long time. It's interesting, it takes that much time. It says it's loading, but it's either the internet or the computer itself. Maybe I would stick with one software so that we don't overload my processor. Right, here we go. Okay, so this base map, it's kinda good. Sometimes people would love when they publish papers or something to use this map because it's a little bit lighter. It's not basy with lots of trees and greens, so it's much better with lighter building images, like if you put the points as like in red and yellow and green, it's gonna show up, okay? So that's one of the benefit of having this maps. Okay, so if you guys remember from last time, there was a way that if you guys remember, if we want to convert from building polygons to building points, what we do, we did actually last time, did we do from polygons to points?
Yeah. Feature.
Okay, so we there's an option called feature, and any feature you can convert it to something else. You can convert it to polygons, you can convert it to rasters. So there's a toolbox here, you have to click on it. This location here takes 1 minute until it loads most of the tools that you have here, and then you can search what tool that you want to use at the moment. Like I want to convert feature to point so that I can convert the polygons to points. So polygons is very good in everything, but the thing is usually when we do analysis, we need every building to be one single point so that we can, like, that's also one thing that's gonna lead to a good discussion. Let's say that this is your hazard map, and you guys remember when we talk about hazard maps, we talk about pixels, right? It was something like this, and every pixel has a specific flood depth. But usually buildings is not a point. Usually buildings is something like, let's say our building is something like this and covers many pixels, okay? So this pixel has a value, this pixel has a value, this pixel has a value. If you wanted an accurate flood depth, you have to account for all the flood depths around the building. That's if you want it that accurate. But the thing is, usually the pixel size, if it's very, very high resolution, it's like 0.5 meter. Let's say that the building is 10 meter by 10 meter or 12 meter by 12 meter. Some people, they would take the average pixel value at the building and they give it to the center of the building. But that's a lot of work. So usually when we do community level analysis, we don't have to go deep in the pixel size. So what we do, we convert the polygon into a point, and we try to extract the value of the flood depths in the center of the map. Without getting averaging of all the pixel values. I'm gonna show you right now. So first, let's convert these buildings, the building polygons, to points. Maybe I would zoom in, maybe here at the downtown. And let me go to search. And then what I'm gonna do is, I'm gonna say feature to point. Or you can search polygon to point. So I'm gonna drag and drop this feature here. And once it's loaded, it's gonna give a default name for the output feature class. And it's gonna name it and give it a default folder. If you wanna change it, you can change it, but I'm gonna say okay right now. And by the way, when you run like a tool like this, here's it shows me the process, like how much time is left or how many percentage is left. Sometimes some processes, in ArcMap, sorry, not ArcGIS Pro, this screen doesn't show up. If you want it to show up, you go to, I believe, customize, and there's something. Oh, I think it's geoprocessing. And geoprocessing options. Yeah, here. If you click on background processing and you make enable, that means the processing is gonna done in the background. You are not gonna see it. It's gonna only show you a bar here that the processing is going. But I have it unchecked, so it's showing me how the processing is going. So you have to uncheck, enable here, and it's gonna show up. Anyway, so right now I have every building as a single point. Let's get to the hazard. I have multiple hazard map for Galveston County, and these hazard maps are based on Hurricane Ike in 2008. Let's go to the raster maps. So I have multiple raster maps. Like I have one, it's called Ike maximum flood depths. What do you infer from depth? Is it elevation? No, it's depth, right? So definitely this flood depth is measured from the ground, okay? The second one, it's called Ike maximum.
Oh, why it's from the ground?
Because it has depth. So the depth is always measured to the ground elevation of this map, like when he developed his map. So when we have depth, it's measured from the ground. That's by default. Okay, here, look at this one. It's called maximum flood duration. Maximum flood duration is not, it's an hours, okay? So the depth and elevation doesn't matter. So it's gonna be like 20-hour, 100-hour flooding. All right, so the second one, it's called Ike maximum wave height. SIG is an abbreviation for significant, maximum significant wave height. And the wave height is still absolute height, okay? Because it's a height on top of the surge. Then you have maximum wind velocity, and then you have maximum water surface elevation. Elevation, that means the water is measured from the dam. You can use either water surface elevation, or you can use the flood depth. Let's take the flood depth. Okay, I'm gonna take it and I'm gonna drag and drop in my maps here. It's gonna take 1 minute to load. Let me close this so that we can. All right, here we go. Look at this. I'm gonna zoom out, zoom to this layer, and you will see the extent of the hazard map. It's covering maybe the entire county. Can you see? Here's my community in this area, and it covered this whole area. And this is the coastal engineer make this boundaries when it provided me this hazard map, but I'm only interested in this area. It's a black and white. When you load a raster map in ArcGIS, it always becomes black and white. If you wanna change this, you go to the symbology of the hazard map. Like I go here and I click, and you can change it to whatever I want. Like I can convert it to blue, and it's kind of more representative of how the flood is. The darker the blue, the more the flood depth is. Okay, so and actually you can do the maximum flood height. So the maximum flood height is 5 meters, and the minimum is almost 0. Okay, so let's say right now I have the building points. Let me zoom in. And by the way, I have right now, my cruiser is like zoom in, like this tool. If you want to zoom out, you can use this tool. If you want to get back to the regular one, you can click on this one. And there's something here, a blue circle that has eye, it's called identity. If you click on it, and if you have the identity active, if you click on any parts of the map, it's gonna tell you what is the information on this map is. Like, okay, I clicked on the map here, it tells me that the flood depth is 0 over there. Okay, and by the way, this is the flood depth. That means this area is 0. There's no flooding. If you click in a building, it's gonna give you all the information about this building. Let's zoom in, and I'm gonna zoom into the downtown. And I'm gonna click on this polygon. Once you click on this polygon, it's gonna give you all the information about the polygon that you have in the shapefile. So that's the identity. If you don't want the identity, and actually, can you guys see the pixels here?
Yes.
The pixel is like huge, like a building can fit in 1 pixel. So usually, and that's actually, can you see this point? It's like almost close to these 4 pixels. But when I extract the flood depths, do you know which pixels are gonna be used of this 4? The pixel that has the point, this pixel. So let's see what is the flood depths at this pixel. Where? I was at which building? This one, right? Anyway, if I zoom in at this one is like in the middle between them. Let's click on this pixel. This pixel has a flood depth of 2.49. This pixel has a flood depth of 2.51. So it's almost 0.02. And actually, this hazard map is not like 100% accurate, so we can't tolerate this accuracy. So it doesn't matter if you subtract it at this pixel or this pixel, not that much, right? Okay, so let's say I want to extract the flood depths. I'm gonna go here at the shape file. I'm gonna open the shape file of the points. I'm gonna open it. And the last field in that shape file is this field. Okay? So let's see when I extract the flood depths, it's gonna add another field. So I'm gonna go here at the search, and you will type extract. You'll find many things that you can extract. If you wanna be specific, I'm gonna say extract point. So there's something that's called extract by point, and there's something called extract values to point, and extract multi-values to points. What we want to do right now, we want to extract a value to a point. If we want to extract multi-values, that means you have 10 raster maps, and you want to extract the value of each map to a point. Like let's say you have a 1,000-year event, 100-year event, 500-year event. You have a list of maps, and you want to extract the flood depths for each one of these events. So you load all these maps in this tool. By the way, you can find this here, like there's, like I can, if you know actually where it is, I believe it was, as far as I remember, it was in the spatial analyst tool. And there's something here that's called extraction. And extraction, there's all the type of extractions. Extract by point, extract by polygon. So I usually use extract multi-values to point, because if I want to extract the wind speed, I do all of them at the same time. So basically, I drag the feature, the points, and from here, I can select, it's gonna show me all the rasters. I only have one raster here. If you have multiple of them, it's gonna be listed one by one. Then I'm gonna name this F depth. And I'm gonna make sure to have the units, just in case if I forgot at some point, what is the unit of this? So let's say this is a 100-year event, so maybe I put 100 at the end, if it's 2. So I name it, try to pick a name that represent what is inside the field. If it's depth, so you have to have depth. If the unit meter, you have to have a meter. If it's 100 year, to put 100. Okay, so when you say okay here, it's gonna take a little bit of time, and gonna extract all the values and put it in a new field. It says completed, but I have to wait until it finishes. So oh my god. It crashed. I had to wait until it finished, and it finished it. That's why you need to make sure to save every time they work on something, so that you don't lose the data. Anyway, let me see if I have this saved. Get the points right away. So tool. If you guys remember, we had extraction and extract multi-values to point. Hopefully it will not crash. let's go to open this file, and you will find this at the end of the shape file. So you will find the flood depths here, all the calculated flood depths here. I'm not gonna put a base map so that we can have the analysis fast. All right, so definitely you will find maybe some flood depths are 0. So if you wanna like arrange them from the lowest, you'll find that some are negative, which doesn't make sense. So if you wanna extract, or if you wanna take all these negative values, because there's no negative flood depths, or if there is negative flood depths, that means it's below the datum, and I'm not interested into. So you can make them 0. Why? Because when we do the MATLAB analysis, our flood depths start from 0, and when MATLAB it checks that there's a negative value, it's gonna stop. So you have to convert everything that is negative to 0. So how can I do that? Okay, so you go to something here, it's called select by attribute. And then you are gonna scroll down. So this is all the headers of these fields. So I scroll down to the last one where I have the flood depths in meter, this one. And I click on it. So it's gonna show up here. Basically, we are gonna write a subcode, a small code here. I'm gonna tell the MATLAB to select the flood depths that are less than 0, okay? So I select the flood depths, and then I'm gonna say, if the flood depth is less than 0, apply. So it's gonna select all the flood depths that are less than 0. Sounds like we have 359 values out of 29,000 buildings that are 0. So I select them this one is gonna show all the data. Right now I selected 359 buildings. So this one is gonna show only the selected data. Okay, so this shows all the data, this shows all the selected data. So now I can take this selected buildings and change their values alone without changing all the values of the other data. So for this selected data, I go all the way here. If you scroll down, you'll find that all of them are negative values. So you can click on this field right like this and right click and make something is called field calculator. Field calculator is you can take these values and make all of them are equal to 0. And then I'm gonna hit OK. So right now I changed the values that are negative and I put all of them 0. Now I can go back to all values and I can deal with the flood depths that I have. All right. So I can go back here. If you wanna unselect or clear the selection, you click on this one. So right now I have 0 selected out of 29,000. All right, so let's rank them from the highest to the lowest. So the highest, the value is 3.47 meter. Okay, so right now I have the flood depths. Let me go here. I will find something called FFE. Yeah, this one. The versed floor, let me see if it has values. It doesn't have values. Oh yeah, okay. Here I have something that's called the foundation height. Most of the data that we have, it doesn't have versed floor elevation. That's rarely you can find. You will rarely in any counties in the US, they can have versed floor elevation. They have ground elevations. Because ground elevation is very easy. They do like satellite images and LiDAR and stuff like this and they can get it. But if you want a versed floor elevation, you have to get at every building and measure how this building is elevated from the ground. And it's a very, very exhaustive and intensive process for the counties to do. So they usually have something called versed floor elevation certificate or elevation certificate, but it's paper based, it's not GIS based. Some counties are able to convert it to GIS and insert this in the data. So what we use as a researchers to infer the value of the versed floor elevation. If we know the ground elevation and if we know the foundation height, we can say that the FFE is the ground elevation plus the foundation height. The foundation height that we have here is in foot. And the foundation height is inferred from the foundation type. Like, for example, we say if a building is on a slab grade foundation, we usually say it's 1 foot above the ground. Like if the ground elevation is 10, so it's gonna be 11. If the building is on a crownless base foundation, we say maybe it's 1 meter or 3 foot from the ground. If the building is elevated 1 story from the ground, usually the 1 story is around 10 foot. Okay? Some buildings are elevated very high. So we are gonna use these values, input, to find out what is the first floor elevation. So, but the thing is, to do this, I need digital elevation map. I need what is the value of the digital elevation map. That's very, very important, because if you want to find the first floor elevation, it's the ground elevation plus the height of the foundation. So we need to find what is the ground elevation. There is multiple sources to get digital elevation maps. Have you guys heard about USGS, the United States Geological Survey? They have information about the ground elevation. Also, NOAA have information about the ground elevation. Like, okay, let's go and search. I will go to Google, and I'm gonna search USGS DEM, Digital Elevation Map, download. And you will find something is called GIS Data Download, with the National Map Data Delivery. So let's try one of these. And then I'm gonna say, let's launch this software. It's called TNM, the National. Okay, so here what we are looking for elevation data. So I'm gonna check this box, and it's gonna tell you there's multiple ways that can give the data to you. I want digital elevation maps. I don't want LiDAR, and I'm gonna select my location, and I'm gonna zoom at Texas. I can put it here, say Galveston. Alright, so this is the location that I'm interested in. And once I click that I want digital elevation map, and it tells you what the final format, usually we deal with STIF format. TIFF. Okay, and then I'm gonna hit search, products. So you will find products here. If you want to know if this map matches the area that you are looking for, so you say, I want to see footprint. So basically it's going to show you where exactly is this map. There's another website. It's much higher accuracy, and I mean, but it's definitely the maps is gonna be much bigger. Like it's NOAA imagery. So you go here, NOAA imagery, and then you click here. If the map got downloaded. Yeah, the map got downloaded. Let's drag and drop this map here and see where it is. Sounds like the map is not. Let's zoom to the later. Where is it? Oh, the map isn't like completely. It's like at the different areas of the shoreline. But I want to see where are our data. Okay, so sounds like this map is here. And our shoreline is here, so you have to download, I believe, most of these map and try to merge them together to get the full map. So which is a really exhaustive process. So I believe I have the hazard map for this, but maybe not on my computer. But anyway, there's another way to do it. There's, okay, let's say, it's called NOAA LiDAR imagery, and basically gives you data for the entire coast. So that's also another way. You go to something that's called elevation or LiDAR, and then this is the areas that covered in the US that they have LiDAR-based digital elevation maps. So I'm gonna search about Galveston, Texas. And then we will find out what products that they have. So this is the area that we are looking at. Usually, I'm not looking at points, because points, that means LiDAR points. I'm not looking to get a LiDAR points because the digital elevation map is like made out of LiDAR. They have lights, and every light has a point, and you take the elevation of each point and convert it to map. We need maps that are already converted. So basically, you can, like, if I click here, when you have your cruiser or something, it tells you where this map is. This is for this area. This is for this area, and this is the area that we are interested in, but it's points. We are not interested in points. So I'm gonna go here to digital elevation map. So this is the digital elevation map that I'm interested in. This one. So when I click here, that has them, which one? This one. The one that doesn't have points, and it's 11 gigabytes. It's a lot. You can actually download this one as well. It's much smaller and actually covers the Galveston Island that we are interested in. So that's a way to download them. It takes some time to download this map, but anyway, let's see if I have the digital elevation calculated here.
So when we import the data from the map, do we need to combine it inside the shape file, or does it?
What is the question?
When I get the data from the map,
That-
for
what
the
map?
elevation.
Yeah, from the digital elevation map that we need to download it from either USGS or from the NOAA. It gives you the ground elevations.
Okay, and when I import it in here,
You put it here.
do I need to do extra steps to show it in SharePoint?
You have to extract the value of the flood depths at each building from the map, the same way that we extracted the flood heights.
Okay.
So it's both are raster map. One is gonna give you the flood height, and one is gonna give you the ground elevation. If you plus them together, it's gonna give you the water surface elevation.
Okay, but we need to do the same process to extract the.
Yeah, we need to do this extraction again.
Okay.
But I don't have time to download 2 gigabyte map. So you download them, load them, and extract them. But here, I already have it done before, like here. The digital elevation in meter. Okay, so I have it here. So let's say that I have done this step. If you want to find out what is the water surface elevation, I can add a field. And this field, I can call it water surface elevation in meter. And then I'm gonna make this as a double, and it says that it's already, this name is already there, so let's put 1 in front of it. And right now I can say that this field is equal to the flood depths plus the digital elevation. So I'm gonna say field calculator, and I'm gonna say that this field is equal to the flood depths plus the flood depths measured from the DEM, the ground elevation. So if you sum these two together, it's gonna give you the total water surface elevation. However, we already have a map for the water surface elevation. Like, it's already given, the coastal engineer already developed. You can compare what we got with what he has. This one. You will find that they are almost matching. This is 3.59 and this is 3.23. This is like 2.91. Yeah, some of them are gonna match, some of them are gonna have some discrepancy, because he might use different digital elevation model. Maybe I used a high accuracy one, maybe he used low accuracy, and that's what coastal engineers do. They don't use big pixel size because they do coastal analysis for the entire coast, so they increase the pixel size. But I use digital elevation map with a very low pixel size and much more accurate. So that's where the differences between this and this came from. This is the water surface elevation calculated from the map that already gave to me, and this is the water surface elevation calculated based on the digital elevation map that I downloaded and the flood depths that he gave to me. Okay, so let's stop for now, and maybe next time we're gonna practice more of this. And I'm gonna tell you maybe the next 3 lectures we are gonna have them online. Like you guys can be home, and then I can share my screen for just the next 3 lectures. It depends. I'm gonna tell you. I'm gonna confirm with you. Right? Okay. See you guys next time.
Thank you.